we're professors who work in machine learning, so we inherently like have a thirst for a more challenging problem. And that's what AI allows you to do, right? It's like it might take away the really simple mathematical procedure, but it allows us to explore a larger feature space. It allows us to explore a one-off problem that we couldn't consider before because we didn't have the data to support it. So I'm not surprised that you and I are on the for side. Hi, and welcome to this month's episode of Engineering Greatness, an original podcast series produced by the American Concrete Institute. I'm Stephanie Paul. I'm an associate professor in civil and environmental engineering at Texas A&M University, and with me today is Danny.
Hey, I'm Danny Snow, Georgia Tech, assistant professor. Yeah, welcome to the chat.
Yeah, so welcome to the podcast. Danny and I actually know each other, so I figured we would start out by letting you all get to know us as well. We can start out with maybe I ask you, Danny, why, or actually, what inspired you to study civil engineering?
Actually, it was kind of random chance. I was actually originally a geology major when I was an undergrad, and um, I don't know. I decided to make a change for it. I really enjoyed math and that kind of thing, so I thought maybe diverge from science, which I do a lot more of now, and kind of focus more on the applied math stuff. I've always enjoyed construction. I did construction when I was in high school quite a bit, roofing and framing and stuff. So I thought that structural engineering would be a pretty cool application of that. When you're young, you just kind of do things, and hopefully the chips settle where they may, and things work out well for you. How about you, Stephanie?
That's kind of crazy. I didn't know that about you because I actually started out as a social work major.
Hmm.
I came to orientation at UT Austin, which is where I went, and I thought, oh man, I love physics. I love math, and I don't know that I'm going to get to take any of those classes here. And so I immediately started searching for other programs and figured I ended up in architectural engineering at UT,
Okay.
mostly because the description on the website was something like engineering for the social good. So I thought it fit, the social work side of what I was interested in at the time with what I was actually good at.
Okay.
And that would challenge me a little bit better.
So you were an archi major. Was that like a 5-year deal or?
No, UT Archie was just a 4-year deal, so it wasn't it's one of a few programs. There are more now, but it was just kind of a hybrid architectural and civil engineering, maybe a little bit more of like a structures engineering focus
Okay.
with some of the architectural studio classes that you do in a traditional architecture program.
Okay, so do you still do any drafting by hand or anything like that?
No, and we didn't at the time. It was AutoCAD. I'm not that old, Danny. All
Okay,
right.
okay. No, I didn't call you on that.
Yeah, I mean, maybe we did do a couple of drawings by hand, but
Right.
AutoCAD was big. Revit was big when I was in college, if that shows, I think
All
we're
right.
similar ages, but yeah.
I dig it. I dig it. Yeah, I knew when I was at KU, I think like quite a large portion of our undergrads were architectural engineers, and I think we
Yeah,
had a
it's actually one
5-year
of the
program.
programs. I think KU, Penn State, and UT were some of the few when I was there, but now there are a lot more. And KU is probably one of the biggest ones. And
Okay,
yeah.
cool, cool. So, are you from Texas then, or is that why you chose UT Austin?
I am from Texas. That is why I chose UT, mostly because my older sister went there and
Okay.
UT blood runs deep in Texas. So I'm from Houston. I went to UT, and then I went to Georgia Tech. But now Texas drew me right back at Texas A&M. Yeah.
Okay.
What about you? Is that why you chose Kansas?
Oh yeah, I'm a Jayhawk through and through ever since I was a little kid. Yeah, I still rep JU or JU KU swag. Fiercely defensive of them despite our performance in the past few years.
Hmm.
My mom still lives in Lawrence. That's where KU's at. So whenever I go back, I go to all the cool spots. So I was fortunate enough. Concrete legend Dave Darwin taught the materials class. He's a past president of ACI. So I took his class and he was just great. It was a lot of fun in the class. The guy's about as knowledgeable about materials as I think probably anybody is. I thought that was pretty cool. And then my junior year, um, I got interested in structures because actually Joanne Browning, she's heavily involved with ACI, taught concrete design. I took that class, and then I was like, hey, this is really cool. So actually, a lot of the professors and faculty there, also Matt O'Reilly at KU, he's more of a corrosion guy, but he taught a lot of the classes as well, and they were so enthusiastic. I joined up, became the KU chapter president, and so
Wow.
yeah, all those people inspired me, and I got into structures, and I thought it was pretty cool.
So you've been a part of ACI since you were in undergrad?
Yeah, I've been a part of
Involved.
ACI since gosh, like 2009 now.
Wow.
So it's a long and storied history. I think I've been to like 1,000 ACI conventions at this point. So
Those numbers don't add up, Danny.
yeah,
Close.
well, it's true. I don't know. I'm seeing 40 coming around the brink for me, so I'm thinking about my age a little bit more recently.
I get that.
So for you, like structures, obviously architectural engineering structures would have been a pretty smooth pathway for you to get into grad school, or did you go practice for a while, or?
No, I did not practice for a while. I'm a perpetual student. That's what I tell all my students now. When I was at UT, I went and told my professors, I'll see you back here when I take your place. I was like so obsessed with UT and the classes and my professors. And like my reinforced concrete professor is the one who wrote all my recommendations. I doubt he remembers me from Adam, but um yeah, I just kind of always thought I would keep going. And I guess I had zero internships. I applied for zero industry jobs, so it was just inevitable. And thankfully,
Yeah.
it's been a good path for me. Yeah.
Oh, sweet, sweet. Um, yeah, everybody, at least a lot of the academics that I know, they all have a different pathway to get to where they're getting. And I know you can probably relate. You have to be kind of a different person to go
Mhm.
into academics in the first place. So it's really interesting to hear your path. I know for me, anyways, it was also a bit of a strange one, like going into the military and
Mhm.
then coming back and going into academia after that time. And then people ask you like, "Oh, hey, were you ever in industry?" I'm like, "Is the military industry? Does that count? Like, what
Yeah.
is
How do you
that?"
match up those two things?
Yeah. So was it like a quite a change for you when you went into research full time, or?
Yeah, when I was an undergrad, I was an undergraduate student researcher, but that consisted of like cleaning the structures lab,
Yeah.
basically, drawing cracks on some beams
Okay.
and taking pictures for the grad students. So I definitely didn't know what I was getting into, which I think allows me to be a better mentor because I feel like most PhD students don't really know what they're getting into.
Yeah.
Um, but I am really glad I left UT. I went to Georgia Tech, obviously where you are now, which is great for so many reasons. You can't do the thumbs up. That's the Aggie thing. That's
Oh,
a
is it?
scam. We
Oops.
own the thumbs up. Yeah, so ending up at Georgia Tech and having like a pretty different, I ended up working on reinforced concrete structures there and doing not experimental work, but a computational project using at the time what I now realize was machine learning to try to like automate post-disaster reconnaissance for reinforced concrete structures after earthquakes, basically. So I think for me, it was just like I just kept putting one foot in front of the other. I don't think I knew like what it was all going to turn into.
Yeah.
But I'm really grateful for the path I took. I just yeah, ended up at Georgia Tech, loved my time there, but kind of always thought I would stay at UT. And then after Georgia Tech, I kind of thought I would go straight into another job, and I ended up in Europe for 3 years in a postdoc, and then going to UT, I don't think I ever thought I would end up at Texas A&M, which is their rival. But here I am, and it's like
Yeah.
the best job I could ever dream of. So
That's
I'm
so
really,
cool. And
yeah.
like, I think maybe it's serendipity. I don't know, but like for your postdoc, you were in, I believe, Switzerland, correct?
Yeah.
I was also in Europe for my postdoc and also in
Yeah.
Europe for my PhD. Like, it's a pretty different experience to go to Europe. Like, you experience a totally different culture and kind of put yourself out there. Like, how did that inform you as, I don't know, a researcher, as a person? Um, like how did that like affect your life experience and your trajectory?
That's such a good question. I want to hear your answer. Um, I would say for me, Europeans really understand how to do life. So I learned a lot of things beyond just like the academic environment,
Yeah,
work-life balance, like an appreciation for culture and appreciation for the outdoors. But then with respect to my job, the European or just like other academic environments are very different than the US academic environment. So it was definitely a challenge to leave,
yeah,
then come back. I'm really grateful that I did. I think it was the people that I met over there are still people that I like look up to, work with, collaborate with. And so it broadens your network. But yeah, coming back, it was like, what am I prepared for
mhm,
this US academic environment? Um, when I haven't been in it for a couple of years. You still like publish and
yeah.
network, whatnot, but I networked in a different community. So I'm the time I spent over there, I would never exchange for anything in the world. But yeah, I want to hear your answer to that.
I mean, I can reflect that. Yeah, well, I went there for my final year of my PhD. My PhD advisor and I, Mo Porgaz, best PhD advisor of all time, by the way, for
Mhm.
anybody listening.
You can't say that. I've got two.
Well, okay, yeah, well, fair enough. Well, the cool thing about my advisor is that he's still my advisor. You know, I still text him and talk to him, and he gives me really useful advice. And the guy's hilarious, so he's great to be around. Um, but so we wrote a proposal for a Fulbright, and I got it, and I went to Finland. Then stuck around for the postdoc. But the coolest thing that I did with that was I learned a second language.
Mm.
So I learned Finnish. Like I'm intelligible in Finnish. I actually took the EU test, and I'm like an upper intermediate. And it's such a
Wow.
different language. It's not a Romance language. It's not a Germanic language. Like it's totally different. The way that they don't use articles. You know, they have a different way of expressing things. They have 20 different words for snow for each different kinds of snow that you have, right? Their culture revol That's when I realized that culture like largely revolves around the language. So it was really eye-opening to me to learn another language. But yeah, I agree. Like they know how to live life, right?
Hmm.
They set hard boundaries. I think Gen Z is doing pretty good at this too in the U.S. Setting hard boundaries on, I'm going to work 40 hours a week and that's it. Yet they do incredible research. Finns are brilliant people. I think on average they're incredible. You can go to the big thing to do there is to go to a karaoke bar. So you can go to a karaoke bar and talk to a random person. They speak three languages, Swedish, Finnish, and English, and they know everything about like geopolitics, like just the average person. And when I came back here, it was like a really good time to reflect on like, what kind of person do I want to be? Like, what am I doing in the US? Like, how do I take this and kind of move forward in a positive direction? And it was really a good reflection time for me. So it was really cool. Also, like professionally, uh, Finland is like number one in the world for inverse problems, which has become a passion for me. Not only in terms of structures or ACI related stuff, but applied math, and it really changed my viewpoint on how problems are solved in general. So, as civil engineers, we generally solve forward problems, but if we look at design, it's an inverse problem. Not going from cause to effect like a forward problem is the inverse problem is going from effect to cause. And so it really kind of flipped my brain on its head, pun intended. And it's just a great experience. So if anybody has an opportunity, or my students have an opportunity to go international, I highly recommend it.
Yeah, same.
One other
I'm
thing, I
sending a
know I'm
kid in
ranting
about
now.
a
Yeah.
week to Scotland. He's on his way. So
Oh, that's awesome.
I think it's pretty important for sure. And now, since I spend time over there, I have a European conference that I go to every year. And this year, the student was like, "Can I go?" And I was like, "Of course you can go. I don't need to go. I've gone for, 12, 15 years. It's your turn." So
Yeah.
I
And
hope, I really hope all my students get that same experience to some extent. I didn't realize that was when you started getting into the inverse problem world. Was that just a coincidence? Was that what your Fulbright was focused on, or how did that happen?
well, my PhD work was on tomography, so like imaging the inside of concrete when moisture flows in it. And tomography, all forms of tomography are inherently an inverse problem. X-ray, CT, CT stands for computed tomography, but that could be any, but it generally refers to X-ray. MRI, that kind of stuff. Um, so that's kind of how I got into it. And then I went to, the hub of inverse problems and stuff like that. The one other thing I did want to say, kind of caveating off what you said, is that I think that studying abroad or however living abroad for that long of time gave me a better appreciation for the international colleagues that I have in the US and my students. Like there is a special place for people like who come to the US or England or whatever other country and do research in a second language. Like
Yeah.
that is seriously impressive. So that's all I want to say about that. I'm
Well,
done.
that and just moving to a new place, like in general,
Yeah.
I think before that, I, most Texans don't ever leave Texas. When I moved to Atlanta, that was a big step for me, and
Okay.
I felt like an outsider to some extent. But at the same time, no, the culture is pretty much the same. Moving to Europe is a total outsider mentality all of a sudden. And so I definitely feel like I can connect with my students who are coming from other places. Um, who are living in a language that's not their own, yeah, in a much different way that maybe everyone can't. And I just feel that like for people around me, you know, in
Yeah.
my everyday life. So I'm glad we both seem to be very grateful for that experience. Yeah.
Yeah, totally. Definitely informative on how I think about many things, even outside of research. Um, so, like, kind of going back to what you were talking before, you had gotten into machine learning stuff when you were in your PhD, or was that when you were in Switzerland?
Yeah, so on my PhD, it was like, well, it was 2009 to 13. So I don't know if people would call it machine learning, but we call it's machine vision, which is a
Okay.
subset of artificial intelligence, where we were basically using, sounds not that far off from your PhD in terms of like using imagery, but we were just using really bad imagery because we wanted to use the cheapest camera you could because we wanted to do this for any environment.
Okay.
Um, and this was 2009, right? So we used little webcams and took videos of post-earthquake damaged reinforced concrete structures, mostly columns. And then I created algorithms that automatically identified what the response was of that column. So how much drift there was post-earthquake. And I did that by like automatically identifying the cracks and the
Uh,
spalling and how much reinforcement was exposed, as well as if I could measure like what the actual displacement was. At the time, there wasn't a whole lot of great image-based tools. So it was just something we built from the ground up. That was my PhD. Yeah. In my postdoc, I didn't really do a lot of machine learning or machine vision. I went kind of a totally different route,
okay.
which was very fun as an aside to started looking into uncertainty quantification and this approach called model falsification that my great postdoc advisor kind of developed, and it was good for me to do something totally different, you know? So I tell my students when they're looking for a postdoc, you can either go kind of down the same route, but try a new problem, or you can do something totally different. Both are going to help you to kind of figure out what you want your career to be, or like your career goals and what the vision for your research group will be. So I'm grateful for that because I was allowed to kind of see two different things and then force my mind to think outside of just my PhD track, you know?
Do you feel like you carried that forward, like as you moved into faculty or just other parts of life that you like, that the postdoc helped you, or do you feel like it was more of like just a linearization point?
I think it helped me. I think it helped me to kind of steer away, like take a right turn rather than just keep going straight. I think the people I met during that time in terms of academic network are people that I value very, very much so. Um, yeah, I think a postdoc is also somewhat necessary now. I mean, you still
Yeah.
hear stories of people who don't do a postdoc and get a faculty position. But in terms of kind of giving you some more responsibility after a PhD, I think for that, it allowed me to get teaching experience that I hadn't had before. It allowed me to get a whole lot more mentoring experience than I had had before. And that is both basically what our job is, I feel like, is writing, uh, thinking of ideas mostly, but then writing and mentoring. And so I feel very, very grateful for the fact that I was able to mentor a lot of PhD students during my time as a postdoc.
Yeah. Yeah,
Yeah.
for sure. I mean, definitely some like tangible and intangible skills gained during a postdoc. I would reflect that as well. Also, it's a heck of a lot of fun. You get freedom to like explore new topics, like you mentioned, and like think about, you know, like what's going to be the next thing, you know. I don't think anyone would have seen the direction that machine learning has taken, right? And rather the trajectory, right? I mean,
Well, some people probably did, but maybe not you and me.
yeah, definitely not me. Maybe Jeffrey Hinton or something like that, but definitely not me. It definitely gave me an opportunity to, at least my postdoc, to start working on machine learning.
Hmm.
So I thought that was fantastic. And then obviously. Now, you and I are very like heavily involved with that. So I mean, obviously, you're a committee chair of the machine learning, so to speak, ACI committee. I mean, are you motivated to like integrate a lot of the stuff that you're doing now with what ACI is doing with machine learning? Or are you more of like a generalist or agnostic with respect to that?
I think because I feel like I've been around it for a long time, which, is subjective and relative. But since my PhD, I feel like I've been reviewing papers on machine
Yeah.
learning. I've been, being asked questions about machine learning. And I've kind of seen the trend from like anti to pro. And that anti was bad because it's like, let us explore, let us, challenge these ideas, but in a healthy way and figure out which problems does it work for and which problems does it not. And then the really pro side of it, where it's just like the hype cycle, right? Where it's super, everyone's very excited about the application of machine learning is also kind of dangerous
Yeah.
because people who don't really know what they're doing are maybe implementing machine learning, or people who do know what they're doing but don't really know like every step of the process and maybe are, just kind of like skipping steps. So I don't remember exactly what your question was, but
I forgot it too, don't worry. It was a very poorly worded question.
no, I'm sure it wasn't. I just kind of started
Um,
talking about two different things, but
yeah, no, yeah, thinking about what you just said, I mean, I'm kind of in the same boat. I mean, I review this stuff all the time. Sometimes it's done well, sometimes it's done poorly. But I'm really still extremely excited by this stuff. I know probably in the past year, maybe a little bit over a year, like the direction that generative AI has gone
Mhm.
is absolutely bananas, man. Like transformers, even coupled with diffusion modules, like these are pretty simple concepts. I mean, for those of us who are lay, a transformer is basically a regular feed-forward neural network with a attention mechanism, which is something in concept very simple, but the ability for these things to generalize and do things that we just couldn't do before is incredible. So I'm stoked about the future of AI, especially as it comes to as it pertains to structures and materials. I think it's going to be really exciting.
Yeah, I think maybe where I was heading before is I have always been pretty pro AI.
Hmm.
You can see there are recordings of me actually doing a debate
Yeah,
for or against, and I'm always for. But I do think people are right to be scared or hesitant at this point. I think the speed at which things are moving forward and, like the industry applications, I kind of say, like, if we don't hop on now, somebody else is going to hop on for us,
yeah,
right? So, us in the concrete industry, practitioners, researchers, everyone, I feel like we have the domain expertise to really like create those tools correctly. So now we would say, 2 years ago it was just LLMs are big, large language models are everywhere. And now we're in this age of agentic AI where every single LLM has been updated into
yeah,
like a personal agent for this. You can have somebody tell you how to manage your house. You can have someone tell your research group how to start out doing research. You can have a TA for your class within an hour, right?
yeah,
And so that is an incredibly useful thing and it's a very exciting thing, but it's like, then what's next, right? And I think it's for me, my research and the world that I live in is a little bit more fundamental. I do some more practical stuff with ACI, and with ACI in mind, just in general. And like the end goal is an application,
Yeah.
but so I can sometimes, have my head in the clouds and be like, oh, there's this really cool, maybe we could try this and maybe we go this direction and we think about this extreme problem, and then you come down and see, oh wow, there's actually so much that's currently being implemented in real life all around you.
Yeah.
Yeah.
So are you worried about the Terminator scenario, Skynet, that kind of stuff?
No, but I do think that like maybe we should take some European work-life balance over here. It's like if there's something that can do part of your job for you, let it. It's somewhat free. I mean, I'm also a little bit concerned about water needs for these servers, but that's kind of an aside that maybe we can't go down on this path. But if you're watching this video, think about it. Um, but no, I'm not afraid that some robot is going to take over our life. I just think there are certain jobs that may be replaced and that we can find paths around that?
Yeah, we've discussed this before. Actually, we had a seminar at SEI on a related topic, and the discussion kind of with the audience kind of went this way. The whole
Hmm.
idea that you brought up, like, is AI going to take our job, right? I mean, we've heard this about so many things, right? If we think about structural engineers, is a finite element method going to take, uh, structural engineers' jobs, right? And
Yeah,
other technologies as well. And I think the reality is it's just going to be transformed, right?
exactly.
I'm also not afraid of this. I embrace it. I think if we're able to take trivial tasks away from structural engineers and allow them to be more creative and explore larger spaces, I think that's a great thing to do, right?
Hmm.
And so yes, I also kind of trend towards the open-minded side of AI. Of course, I should. I work on this, right?
I know I was going to say we're professors who work in machine learning, so we inherently like have a thirst for a more challenging problem. And that's what AI allows you to do, right? It's like it might take away the really simple mathematical procedure, but it allows us to explore a larger feature space. It allows us to explore a one-off problem that we couldn't consider before because we didn't have the data to support it. So I'm not surprised that you and I are on the for side. Yeah.
Yeah, yeah. I mean, I'm pretty biased, I guess, as you are, maybe to a lesser extent than me. But I think about the potentialities of AI, and I think about where will this stuff go with respect to being able to extrapolate. Obviously, fitting between a space and exploring that space is great, but how much can it actually think outside the box? This kind of stuff gets
Yeah.
me excited. Who knows what we'll be able to figure out with this, right?
That is pretty much the entire research question of my research group, right? So every problem that we try to address in my group is if you have a data point that is far outside, it's an extreme value, it's not actually an outlier, right? How do you create, we don't have anything that can deal with that, right? If you don't know the physics,
Yeah,
you can't understand what that far out data point is. If you've never seen it, you can't figure out what that far out data point is. So if you think about concrete, you think about 3D printed concrete, right? In order to actually implement 3D printed concrete, we have to do tests. We have to test the material that's printed, then we have to test the material when it's printed into a structure. And so all of that takes time.
yeah.
And what I think AI or machine learning allows us to do is find another path around that, which then still is extrapolation. So that's what my group focuses on is trying to figure out, can we figure out a way, a technique that allows us to extend knowledge from one domain to another or one distribution to
Hmm.
another, which in its sense, at the end of the day, if you're looking at the data in the right way, it's not actually extrapolation, it's interpolation. It's just kind of like reframing what should the data be so that you can interpolate to this far off data point rather than like using just this data down here, like use the data all around it kind of thing. So, because these models are so powerful in interpolation, so if you can find the right interpolation strategy that is then viewed as extrapolation, yeah, I think the opportunities are pretty endless, but we'll see if they end at some point.
That's pretty dope. So like the like sort of like extreme events kind of mentality there. Like what kind of applications are you looking at with that?
Yeah, so most of my research, like you're alluding to, is at the intersection of machine learning and natural hazards engineering, because we're
Okay.
saying, okay, what happens if there's a magnitude earthquake that we've never seen before? What happens if there's an earthquake in an environment we've never seen before? What happens if we think of this new retrofitting strategy?
Mhm.
How do we actually get it implemented quickly? Because we need it quickly, right? So rather than having to do all of the testing. So essentially, my work is focused on reducing our reliance on physical testing so that we can predict for some new scenario. And we do that at a bunch of different levels. So most recently, we got a project to test from scales, extrapolating across scales, which would then allow you to better understand how structures perform under extreme wind loads. So that's kind of that problem. And then in the ACI world, we have a project to kind of extrapolate across different from the ACI Foundation across different types of mixed designs or kind of one-off designs or environmental conditions so that we could, maybe some sort of material has been tested a lot of times under normal operating conditions, but then what happens if it's in an environment that's more corrosive, right? Can we use just a couple of data points to figure that out? Yeah.
Very, very cool stuff. So
What about you? What's your excitement about machine learning and your research right now?
everything. I'm like really a generalist when it comes to structural engineering. I mean, I've worked on material structures. Right now, I do a lot of non-destructive evaluation stuff, structural health monitoring kind of work. But most recently, we've sort of strategically shifted towards looking at structural design as a learning problem. So the basic premise here is that um, how do we do, for example, conceptual design, the early phase design? How do we do this? Well, typically we take an engineer with some experience and they do a guess and check trial and error process until they converge on a suitable design based off the design constraints. Well, what is that? That's human expertise, right? Can we substitute that with machine expertise? And so that's one of the topics that I'm working on. We just have an open source package come out, which is good fun. Um, Turns out this is one of the areas of machine learning that maybe is a bit more in the future. I think there's been a lot of resistance towards this recently, but I see it more as an assistant than I do a replacement, which is kind of what we're pushing there. But it's a fascinating field. Um, we've had some models recently that can do some really really impressive things, like um, uh, kind of interpolate across multiple design spaces, including multiple load cases simultaneously, which is a notoriously difficult problem to do, even with conventional methods. Maybe two or three load cases can be solved simultaneously using a regular optimization algorithm, but these can solve for arbitrary simultaneous load cases for multi-span continuous systems or very highly indeterminate systems as well. So it's able to do some really cool stuff, and this is like just a few months old, so we're really excited about where this is going to go. So that's one of the things we're looking to do, and then also, kind of how do we incorporate these kinds of learning into like committee work, like things like related to structural committees, ACI related things. How do we integrate some of the modern findings into more pragmatic applications? As you saw at SCI, there was an engineer there from Thornton Thomas City that was presenting some really cool recent works related to machine learned design of framed structures and stuff, like things that they're using for their own benchmarking and their initial design
Hmm.
analysis, and how do we rope those things together and have some fun with it? So that's
Yeah, I
kind of
don't
what
think
we're
it's
doing.
far off. I don't think your work is far off, and I don't think any of it's really far off. I think even if you just look at the pace and how it continues to increase, it seems like you're doing some cool stuff, and it'll probably be in practice before we know it, you know?
These things do move quickly.
Yeah.
I want academia to move as fast as industry is on this because
Well,
they see the value in this. So
yeah.
somebody's got to push, and I think that's um, younger generations of researchers right now are really, really quite excited about this kind of stuff, and so they enthuse me. I have my own postdoc here, and he's stoked about this, and he's working on this problem and really enjoying it as well. So it's
Same.
fun to see the excitement, and at ACI, I talked to a lot of young researchers about this, either through the 1, 2, 3 poster sessions and presentations. It's really cool to chat with them and see their enthusiasm.
Yeah, our committee 135 is like very well attended, lots of great people who are trying to really be invested in the work that we're doing and just like so many really cool presentations from industry and academia. So I definitely think there is an opportunity to highlight all the cool work that's been done. I guess maybe to wrap it up, we could talk a little bit more about ACI. You
Yeah.
said you were like involved in ACI when you were an undergrad. Did you just stick with it continuously, or how did that look?
Yeah, I mean, I did. Well, I was in the military for quite a long time. Well, because I'm paid to find long years, anyways. And so I basically did nothing during then. It's kind of hard to do when you're like in
Yeah.
Afghanistan. So I kind of avoided it at that point in time. But as soon as I came back, I was pretty fortunate. I had the GI Bill to do my PhD. So once I joined Mo's group at that time, again, that was a long time ago as well. Um, I got back into ACI, and he's very involved with ACI. So it was pretty easy to rejoin and get back into the research community there and that kind of stuff. But yeah, I've been a part of ACI for a long time. Like even if I stopped doing anything in concrete, I think I would still be a part of it. I have so many friends and colleagues here that I love to see, and it's always good to go there and see the new research and see what's going on with the committees and stuff like that. And ACI has a blast as well. So
Hmm.
this is an indefinite thing for me for sure. How
Cool.
about you? So you did you join after undergrad then or?
Yeah, I joined very recently.
Okay.
The main thing I was involved in undergrad and grad was, or mostly grad, was ERI because I did earthquake related stuff. So I
Okay.
was like president of that. I was very involved in the Earthquake Engineering Research Institute and student chapter of that. And then I didn't start getting involved in ACI until I came back from my postdoc and started out this my faculty position. And people reached out to me from ACI, like the ACI Foundation. I did some technology forums for them and some webinars. And through that, met a number of people and got roped into or like looped into ACI and some committees. And obviously now I go every year, every twice
Yeah.
a year. I enjoy it. I guess I'm like, I think that's probably where I met you. It was either there or SEI.
Yeah, ACI actually for sure.
Yeah. Met wonderful people, really love my committee and the people that I work with there. And yeah, I have gotten more invested in what goes on through mostly being a committee chair. But yeah, I wasn't involved in ACI as a student, but I am heavily involved in the students at Texas A&M who are in our ACI chapter now. So it's a fun thing to be a part of.
Yeah, it's cool. It's really cool when you have students getting involved with this stuff too, right? Like
Mhm.
whether they're doing presentations or editing some kinds of documents or whatever. We do a lot of things. But it's really fun to see them progress too and get excited about ACI. I mean, I think about my advisors in the past, and I'm pretty much just mimicking them in a lot of ways because if I can instill that kind of enthusiasm for students to do ACI, I'm like, hey, not too bad.
Yeah,
So. Yeah, it's a really good experience. So well done, ACI. Hey, Steph, it was great talking to you today. Really enjoyed the conversation. I know we'll continue this in the future, if not at the next ACI convention. So great talking to you.
absolutely. Yeah.
So for everybody else out there, thanks again for joining us, and thanks to everyone for listening to this month's episode of Engineering Greatness. Join us each month as ACI brings together pairs of young professionals in concrete industry to engage in intimate conversations about their life and work. Be sure to subscribe to our podcasts on Apple, Spotify, Google, or wherever you listen to your favorite podcast. And for more information on ACI, visit us at concrete.org. We'll see you next time.
Bye.